Hi everybody, in this video we're going to be looking at the sine curve. Now we've got this activity here and I'm not sure how many people have gone through this, but I just want to go through and make sure that everybody understands how this curve here works, and particularly we're looking at the A, the B, the C, the D. So we're going to use our Desmos calculator, which is pretty good for this. Alright, so that's our normal sine curve. Notice it starts at 0 and it's got a distance here of about 2 pi. So if you're clicking on there, it shows you the distance. Alright, so if I put in a curve called 2 sine x, what does it do? Oh, it looks like it doubles the height of the wave and it cuts the x-axis at the same point. Let's try another one. Let's do minus 3 sine x. So that one there, the minus inverts it and it makes it a height of 3. Alright, so the amplitude of the wave has been affected by this. That's what it's doing. Alright, so I think that one there, sort of, it's pretty easy to work out what the A does. Let's look at the B value. Right, let's try sine of 2x. So it makes the wave, the period of the wave shorter. In fact, if I actually sweep out 2 waves here, that's one wave, and then that's another wave. So for one normal wave, which is the red line, we're now getting 2 waves here. All right. Over here we've got, let's do sine of a half x. So sine of 0.5x. So this is the black line. So the red line here is normal, that's one wave. The black line's only a half a wave. All right, so you could almost say that number in front of the x tells you the number of waves that you get for every one normal wave. Let's just try another example. Let's do sine of 4x. So again, we'll count the number of waves. We've got 1, 2, 3. We've got 4 waves for our normal 1 sine x. All right, so the B value tells me the number of waves that we will get for every one normal wave. That's how I remember it. So you can find a way that you remember it. The next bit is the D value. Let's do that next. Good. Plus, well, this is sine of x. So let's do sine of x plus 2. It's just shifted everything up too, hasn't it? So it's made the median part of the wave, or the rest position of the wave, it's just increased that by 2. All right, let's try that with sine of x. Take 3. And it's pulled everything down 3. So the rest position of the wave is around 3 now instead of around 2. All right, that's great. Now the next bit I have to do is the C value. Let's do sine of x take 1 and see what happens. So what's actually happened here is that starting position of the wave has been moved across 1 in that direction there. Well, let's see what would happen if I did sine of x plus 1. Just do it in this one here. Make that a plus instead. Well, okay, so it's moved it across that way, plus 1. So if you go plus, it moves it to the left. If you go take, it moves it to the right. Let's try 2 then. See what happens there. It's moved it to the right, to the left too. We take that. This is why I love calculators and graphing tools, is you can see what's going on. So that's moved it to the right too. So I think we know now how that whole equation works, and that's what that investigation was about, is learning about the sine curve. Now the next part of what we've got here, if you come into your OneNote, down the bottom here, we've got a sine curve fitting sheet. All right, so that's the next part of what we want to do, is we want to be able to predict what's happening with the curve based on the information. The activity that you'll need to do for this is to be able to sketch what's actually happening in these particular things here. All right, so if I give you this particular example, for looking at a half sine x. For some reason I've scribbled over these ones. Let me just blow that up a little bit. So half sine x means that I've only got half the amplitude and it's a normal wave. So it's just a normal wave going half the distance. Right? This next one, 4 sine x, means that I should have to draw 4 waves for every one normal wave. Excuse me. And so what I do there is I think about that. I have to draw a normal wave for every half a wave, quarter of a wave. So I'm going to have 2 waves for that position there. Right, and then I have to draw another 2 waves there, and it's got the same height. This next one, if I do this next one here, for some reason I can't scroll down. For the next one down here, I've got half sine 2x. Means I've got to have 2 waves for every one normal wave, and it's got to come down instead of going up. Right, this next one's sine of a half x. If I did that one there, what I'd have to do is I only get half a wave. Alright, so then that would mean that I would have to, and it had the same amplitude. So I'd go down like that, and it'd come back there like that. So that would be that one there. So I'm showing you what you're doing there. This next one, minus sine x. That wave there is wrong. So let's do the proper one. So minus sine x, which is the normal wave, it just means it goes the opposite direction. Well, it needs to be more curved than that. Alright, so that's what my minus sine x would be. Then when I'm going 3.5 sine of a quarter x. Now, a quarter x means only getting a quarter of a wave, but I've got to go to an amplitude of 3/2. So I'll go up to the top line. Anyway, I hope this helps you fit the curve. I'm going to do another video in a second, which is going to go through the other sheet. Alright, so that's the plan.